The Fermi Paradox is a well-known problem in the field of astrobiology and the search for extraterrestrial life. The paradox poses the question, if intelligent extraterrestrial civilizations exist, why haven't we found any evidence of their existence? With all the data and statistics collected in a split second, AI technology has enabled us to observe things with new perspectives, and that was exactly what was needed. In this video, we're going to take a deeper dive into this paradox and see what the most recent AI replied when researchers proposed the question, so make sure to watch till the end. The paradox is named after the physicist Enrico Fermi, who is credited with first posing the question during a conversation with colleagues in 1950. It raises an important question about the likelihood of intelligent life beyond our planet. If the universe is as vast and diverse as we believe it to be, then it stands to reason that there should be other intelligent civilizations out there. However, despite decades of searching for evidence of extraterrestrial life, we have yet to find any conclusive proof that it exists. There are several potential explanations for the Fermi paradox, some of which are more plausible than others. One possibility is that extraterrestrial civilizations simply do not exist. This is certainly a possibility, although it seems unlikely given the vast size and age of the universe. Another possibility is that intelligent civilizations are rare and that we simply haven't found them yet. Despite decades of searching for evidence of extraterrestrial life, we have yet to find any conclusive proof that it exists. However, this has not stopped scientists and researchers from continuing their search for signs of life beyond our planet. In fact, the search for extraterrestrial life has become a major area of focus in recent years, with the new discoveries and technological advancements bringing us closer than ever before to answering whether we're alone in the universe or not. Enrico Fermi is not only the only scientist to have made significant contributions to the study of the paradox. Other notable scientists who have contributed to the understanding of the paradox include Frank Drake, who developed the Drake equation to estimate the number of intelligent civilizations in the galaxy, Jill Tarter, who has spent her career searching for evidence of extraterrestrial life as the director of the SETI Institute, and Stephen Hawking, who famously warned against attempting to make contact with extraterrestrial civilizations for fear that they may not have best interests at heart. Despite the lack of concrete evidence, many scientists remain optimistic about the possibility of discovering extraterrestrial life in the future. With new technological advancements and a growing interest in the search for extraterrestrial intelligence, it is possible that we may one day find evidence of life beyond our own planet. Until then, the Fermi paradox will continue to be a fascinating and thought-provoking puzzle for scientists and the general public alike. The Great Filter hypothesis is a proposed solution to the Fermi paradox by an AI, which asks if intelligent life is so common in the universe, why have we not yet detected any signs of them? The hypothesis suggests that there's a barrier or obstacle that prevents civilizations from advancing beyond a certain point, and that this barrier may be responsible for the absence of alien life in the universe. The concept of the Great Filter was first proposed by economist Robin Hanson in 1996. Hanson argued that there must be a reason why we have not yet detected any signs of advanced extraterrestrial civilizations, and that the most likely explanation is that they do not exist. He suggested that this was because there's a great filter that prevents civilizations from advancing beyond a certain point. Hanson did not suggest what this filter might be, but instead proposed that it could be any number of things that prevent civilizations from surviving and thriving in the universe. Since then, many scientists and thinkers have proposed different theories about what the Great Filter might be. Some suggest that the development of intelligent life itself is incredibly rare, and that we may be the only intelligent species in the galaxy. Others propose that there's some sort of cosmic catastrophe, such as a supernova or gamma-ray burst, that wipes out any civilization before it has a chance to develop spacefaring technology. However, the most popular explanation for the Great Filter is that it is something that lies in our future. This means that there is some sort of challenge or obstacle that we have yet to overcome, and that it may be so difficult to overcome that no civilization has ever been able to do so. Some suggest that this challenge may be technological in nature, such as developing faster than light travel, or harnessing the power of a black hole. Others propose that the challenge may be societal, such as avoiding catastrophic climate change or avoiding a global nuclear war. One of the most significant challenges that any civilization must overcome is the problem of sustainability. Any civilization that is capable of spaceflight must have a highly advanced technology and be capable of extracting resources from its environment on a massive scale. However, this kind of resource extraction can be highly damaging to the environment and can have long-term consequences that are difficult to predict. For example, the use of fossil fuels has led to a significant increase in atmospheric carbon dioxide levels, which is causing global warming and climate change. If a civilization is unable to find a sustainable way of extracting resources from its environment, it may face catastrophic consequences that prevent it from advancing beyond a certain point. The great filter is that civilizations may be vulnerable to self-destruction. This could happen in a number of ways, such as through war, climate change, or ecological collapse. For example, a civilization that's highly dependent on fossil fuels may be vulnerable to the effects of climate change, which could lead to catastrophic consequences that ultimately result in the collapse of the civilization. Alternatively, a civilization that develops highly advanced weapons technology may be vulnerable to war and destruction, which could wipe out the civilization entirely. Perhaps the great filter could also be a natural or caused calamity. Humans bend nature to suit themselves, disrupting the ecosystem. The development of highly advanced technology may also pose a significant challenge to civilizations. Any civilization that develops spacefaring technology must have a highly advanced understanding of physics, mathematics, and engineering. This kind of technology can be highly complex and difficult to develop, and it may require resources and knowledge that are not available to all civilizations. For example, developing faster than light travel may be impossible, or it may require resources and knowledge that are simply too difficult to obtain. The great filter is that it may be related to the evolution of life itself. Some scientists suggest that the evolution of complex life forms is incredibly rare, and that it may be a highly unlikely event that occurs only under very specific conditions. The great filter is that it may be related to the evolution of complex life forms. Some scientists argue that the development of complex life is incredibly rare and that it may be an unlikely event that occurs only under specific conditions. This idea is based on the observation that despite the vast number of potentially habitable planets in the universe, we have not yet detected any signs of intelligent life beyond Earth. The evolution of multicellular life requires the development of specialized cells that can work together to form tissues and organs. However, the evolution of specialized cells also creates new opportunities for disease, as pathogens can evolve to take advantage of these specialized cells. This can lead to a situation where the benefits of multicellularity are outweighed by the costs of disease, making it difficult for complex life to evolve. Another possible explanation is that the evolution of complex life is dependent on rare events, such as asteroid impacts or other catastrophic events. The great filter remains a fascinating and enigmatic concept that continues to puzzle scientists and philosophers alike. The Fermi Paradox is very unsettling. If there are no aliens, then we're alone in this never-ending stretch of space. And if there are, then we're doomed. But for now, every solution is just a speculation. Anyway, don't forget to subscribe to our channel and hit that notification bell, as we make mind-boggling videos for you to wonder. And we won't stop, not until our understanding of the universe and our place in it continues to evolve. Are we alone in the universe? And we'll make a video on it when it finally is answered. For now, you might like this one.